Have you ever wondered why the world appears in certain colors? Why is it that the ocean's blue and the grass is green?
In order to understand color, we first need to know about the basic properties of light.
Light travels as waves.
Dun 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 dun. Charge! Dun 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 dun.
No, Lars, not that kind of wave. All light waves have a characteristic wavelength corresponding to the distance between identical points on two waves. These sizes can vary from extremely small, dangerous gamma rays to mile-long, harmless radio waves. But we're only going to focus on a small region known as visible light.
Visible light ranges from purple at around 400 nanometers to red at around 700. These are the only wavelengths that our eyes can distinguish. But how exactly do we perceive color?
Well, Lars, the eye has special cells known as cones, which help distinguish between the different wavelengths of light.
Humans have three kinds of cones. Every color that we see is based on the amount that that color stimulates each particular cone.
So essentially, there are only three primary colors, and everything else we see is just a secondary mixture of those three. A typical example of primary colors comes from the world of television and computers. They use red, green, blue, as their primary colors. Ooh, it made purple.
Different wavelengths of light can be bounced off of, transmitted through, and absorbed by various objects. This combination of things, combined with ambient lighting and our own eyes' abilities, affect how we perceive color, like this green grass.
One great example of how we perceive color comes from the magnificent blue, smog-filled California sky. On a clear day, the sky appears blue, but the light coming from the sun is white. So what gives?
Longer wavelengths, like red, pass through the sky relatively undisturbed, but blue light is readily scattered by molecules of nitrogen and oxygen in the air.
When the air molecules in the atmosphere encounter the blue light, they scatter them in all directions, which is why, no matter where you look in the sky, it appears blue.
So there you have it. Everything from the sky being blue to a football being brown results from the absorption and transmission of various wavelengths of light. Well, that's about all the time we have for today. If you'd like to learn more about science, email us at bswbproductions@gmail.com. And remember, if you've got a question,
We'll find the answer.